Let's take a look at one of my first ever test lamps when I was an apprentice electrician back around about 1980, and this was what I could afford because a proper set of test lamps at that time was a lot of money. And this is a very simple yes-no. It's got two LEDs, plus and minus. It says Autolec. I think it was sold for general electrical use, but also to the automotive industry. And the specification says 4.5 to 450 volts, AC or DC, max 500 volts. Oh, let me just zoom down this because that's better. Oh, too much zooming. Made in West Germany, which is quite surprising. ED 30 seconds, I guess that's ultimately the duty cycle. And 1 to 10 milliamps. Then it's got a time in milliseconds, presumably for this of like the initial current pulse. And it works. It still works even at this time. I'll do something highly dubious here. I'm going to jam open the safety shutter on, let's not do something terrible that's going to trip all the power to the accommodation in. If I put this in here, you'll see the LEDs will flash briefly on 240 volts and then dim down again. So initial flash, they dim down, they are still lit, but they're glowing quite dimly. And the reason for the initial flash is because the circuitry used in this is still used in modern testers. So let's open it up. I've clearly opened this in the past. As I did, I opened everything. And I have to say, oh, excuse the squeaky noises. I have to say I use this in electrical panels that these days I might not use something like this. I'd rather use Fluke for something like that, just for the safety aspect of it. Though having said that, the construction of these is relatively simple and the risk of them exploding horribly isn't too high. So this part's to reveal dust inside for a start, because this has been in the toolbox for quite some time, a past toolbox, an old one. And it's got a very simple circuit board in here. It's the synthetic resin bonded paper type circuit board with the two LEDs in inverse parallel and a very specialist thermistor here that is a PTC thermistor. As the temperature rises, its resistance rises. The thing also has a fairly deep flash guard lip around that. So I mean, it's designed fairly sensibly. So let me just pause momentarily to reverse engineer this. No point in taking a picture because it's a very simple circuit. It's also worth mentioning that it's modular. It's designed to just plug together with this circuit board. Right, tell you what, one moment please. I'm just going to draw the schematic. So here's the schematic and it's super simple. It has a very odd, I guess this is custom designed for the purpose. This PTC thermistor is based on a ceramic tube with a coating of the material around the outside and then a wire wrapped around the end and soldered, and then it's put through the circuit board. And it looks as though from the design of it that it was designed to possibly take the little button type PTC thermistor as well. But if we take a look at the schematic here, the value initially starts at just over 4,000 ohms, and it's in series with two parallel LEDs. These are old LEDs. They're like the old 660 nanometer type deep red LEDs. And these days, if you use the more sensitive LEDs, as testers do, they'd be brighter. But at 450 volts, which is this sort of upper standard rating, initially this resistor will pass 108 milliamps, but it will be very brief because as soon as it heats up, its resistance increases. And it will dissipate 4 to 9 watts, so that will get hot very quickly. And that's why you get the brief flash when you put it across the sort of higher voltages before it tames down to a lower level. And you see it tail off until it reaches an equilibrium current that the resistor is at a sort of temperature that it limits the current to a point that it just hovers at that resistance. And the LEDs will glow at that level. If put on 240 volts, as I just did, the initial current will be 58 milliamps, which is more reasonable, but it will dissipate 14 watts from that resistor, which will again heat it up, and it will stabilize down to a much lower current. 120 volts, it's 29 milliamps, and it dissipates 3.5 watts. It will light quite brightly, but it will tail off. It's much slower in the lower voltage. 24 volts, it will pass 6 milliamps and just 14 watts, I don't think it'll even reduce in resistance, and 12 volts, it'll just pretty much pass 3 milliamps. And at that, the LEDs will be quite dim. I think it was from the Autoelec thing. Maybe it was aimed at the automotive industry. This was a badged version for cars, for just probing about in the electrics associated with vehicles. But that's very similar to the modern ones. The modern ones, instead of using this strange tubular construction where it's that tube with the coating on the surface of it and then the sort of metallized ends and the wire wrapped round it to make the connection, the modern ones tend to use the little slug of material with a lead soldered on that side, and then it's like the other side has the lead soldered on the other. And it's the sort of standard format. And you find this a lot in the basic testers. I think you even find them ultimately in some multimeters as protection circuitry. Because these little things, they start off with that high resistance to limit the current, but then they quickly go higher resistance to limit the current even further to safe levels. But that is very, very simple, refreshingly simple. Even the ones that give you the multi-voltage indication, they will often have two sections of circuitry. The multi-voltage one, which is based on a divider, a resistive divider and little transistor switching LEDs, but it also typically has this little circuit at the bottom with its own little thermistor just for that polarity indication and the sort of basic voltage test that, you know, it's a basically double duty device. But it's neat. The LEDs will indicate the polarity. Say, for instance, this was put onto the positive connection, this to the negative. The current would flow through this LED, and that would show what connection that the probe was actually on. Very simple. I do feel slightly squirmy seeing inside it now, that I poked that into quite big industrial panels when I was young, but that's what we did. And it never blew up, which is also reassuring. But still, it's useful. The temptation is actually almost to change these for brighter LEDs, which I don't have here at the moment, and perhaps use it for low voltage use, because it is a very compact and handy little tester. It's quite a neat little thing. So quite pleasing actually. Quite nice circuitry, that pure simplicity of just the thermistor and the two inverse parallel LEDs. Very nice.